Hi, I'm Emily from the Pencil Room Online, and in this video we're going to talk about two-point perspective, what it is, how to use it, when to use it. If you're new to using linear perspective, it would be a good idea to check out my video on one-point perspective first, which covers the basics. Otherwise, let's get on with it. I'll go through the technical stuff first, and then I'll take you through a practical demo. And if the technical stuff is a bit too much, then go on ahead and do the practical exercise, because I find that actually practicing a concept really helps me to understand and retain the information. You can draw along with me, and that way you'll also have your own visual diagram to refer to. So what is two-point perspective and when can we use it? Two-point perspective is a way of drawing an illusion of three-dimensional space onto a two-dimensional picture plane. In other words, creating a 3D looking drawing on our flat piece of paper. It's called two-point perspective because it uses two vanishing points. When we talk about 3D, we're talking about measuring the things around us as having width, height, and depth. With one-point perspective, only one of those dimensions, the depth dimension, is treated as having perspective. Switch now to two-point perspective, and 2 out of 3 dimensions are treated as having perspective. Like one-point perspective, two-point perspective is just a system we can use, and sometimes it will be appropriate to use it and sometimes it won't. It's most suitable when you're drawing buildings and cityscapes, objects that are cuboid or box-like in shape, which have equal right angles and which are viewed from a corner. To explain two-point perspective further, I'll demonstrate how it works using my sketchbook, and I recommend you draw along with me to get a really solid sense of what's happening when we use this system. To be able to use this system, we have to rotate this box so we can see two sides at once, as if we're viewing it from a corner. In two-point perspective, the height dimension is always vertical, it never changes. The width and the depth dimensions are the ones that recede back into space to the vanishing points. So let's have a go at drawing this box from the corner. Draw a horizontal line or eye level, and let's place the first box at our eye level so it will cross over the eye level line. The height is always going to be vertical, so we can draw that first and draw it however tall you want the box to be. This is the corner of the box that is now facing us. Now we're going to add a vanishing point at each side. Add these close to the edges of your page. If you're interested in exactly where you should put the vanishing points, we'll cover that later in the video. Now extend lines from the top and the bottom of this corner of the box out to each vanishing point. This gives us the angle of the two sides receding back into the distance. Use a vertical line to add in the two back corners of the box that will be visible to us. Remember, if you're drawing the height of something, it's always going to be dead vertical. Darken up the edges of the box so you can see it clearly. You can draw any size or shape box above or below the eye level. If we move the box below the eye level, we can see the two sides, and we can also see the top of the box. Start the same way by drawing the height of the front corner first, then extend guidelines to each vanishing point. To form the top of the box, we simply extend a guideline from the back corner to the opposite vanishing point. And this is where people can sometimes get a little bit confused, and it may just take a little bit of moving your ruler around until you find the correct vanishing point. What's going to work to create that back edge of the box? You can go ahead and experiment with different boxes around the picture plane, either above or below the eye level. If you get stuck, just remember these rules for two-point perspective. The height lines will always be vertical. Any other lines are always going to connect to a vanishing point. There's no random lines or angles. So just a quick interjection here from the future, because on editing this video I realised that the next part gets kind of technical. We're going to talk about accurate placement for the vanishing points, and also about our natural range of vision, which in linear perspective is also sometimes called the cone of vision. But I just want to make it clear that you don't need to know or understand this information to be able to use two-point perspective. It's just extra info for those people who like to know how these things work. Let's get on with it. Where to place the vanishing points. If you've had a play around with two-point perspective, you may have realised that it makes a difference where you put the vanishing points. If you put them too close together, like this, you'll get something that is distorted and doesn't look right. That's because we're squashing a lot of information into a smaller space, and it's a lot more visual information than we would naturally be able to see in our range of vision. I'm going to try and explain where to put the vanishing points, but keep in mind that I approach this as an artist and not as a physicist or an architect, so hopefully it makes sense, and you can let me know what you think in the comments. The natural range of vision for a human is about 60 degrees, and you can test this by holding your hands together in front of you and then moving them apart, and you'll be able to see your hands fairly clearly until they go out past around 60 degrees. When they're at 90 degrees, you'll be able to use your peripheral vision, and when they're either side of your head, you won't be able to see your hands at all. So that's the first thing to understand. We can only see a limited amount of stuff when we're looking in any one direction. Imagine you are outside in a city and you're looking in one direction. Here is your 60-degree range of vision where everything is going to be pretty clear and in focus. Look what happens when we squish in all of the visual information around us, the whole city scene, into our 60-degree range of vision. It's going to look weird because we can't see all of that unless we're standing very far away, in which case a cityscape could fit in here, but it would be tiny as if it's way in the distance. The second thing to understand is that 1, 2 and 3-point perspective systems are based on drawing squares and cubes, objects that have 90-degree angles. So here's the way I think about where to put the vanishing points. When you're standing directly in front of a cube-shaped object, like a building, the two sides are at a 90-degree angle to each other. And say you're standing right up against the corner of the building, you put your arms along each side of the building, your arms will create a 90-degree angle, and the vanishing points will be at a 90-degree angle from where you're standing. If you were to take a step back, in order to create the effect of perspective, we need to maintain a 90-degree angle between the vanishing points and where we are standing. And if we took another step back, again the vanishing points need to be at a 90-degree angle from our standing point or our station point. So what does this all mean to our drawing? It means to get a sense of perspective that is realistic and not distorted, we need to apply an imaginary station point where the viewer is standing, and from here we can create vanishing points at a 90-degree angle. And then remember the 60-degree range of vision. Anything we draw should be within a 60-degree angle from where that person is standing, because that is the area that is visibly in range. So to summarize that, the rules of two-point perspective are there are two vanishing points. Two dimensions are affected by perspective. That's the width and the depth dimensions. The height dimension is always vertical. Vanishing points are at a 90-degree angle to the standing point or the station point. And the drawing fits within a 60-degree angle from the station point. That's the natural range of human vision. I hope that makes sense. If you've got anything to add, please feel free to do so in the comments. There are some other great YouTube videos out there if you want to get more into the technical side of things. To find them, you could try searching for the term cone of vision. In the next video, I want to show you how you can actually use that knowledge of two-point perspective when you're drawing a subject. So I hope you stick around and I'll see you in that video.